we have seen there are two different interfaces. There are two different interfaces who extended who extended collection interfaces. Correct? What are they? One is the list interface. Other one is set interface and queue. Right? Priority queue or queue interface we have seen. Right? So now DQ. So now we are not going to discuss about it, but we are going to discuss about the set interface. Let's try to understand what is the set interface. Right? Try to understand what is the set interface. Set. Set. Set interface is also an interface which is like a bag. When it comes to list is like an array, right? We have seen it. So the specific position, this, we have seen that, right? So when it comes to the set interface is like a bag. What is like a bag means? So here it will not maintain bag will not have any. Suppose you keep putting the elements into the bag, so it will not maintain any order, it will not maintain any position, right? Okay, it will not maintain index. It will not maintain index. It will not have any index. No order. No order. The major difference is no duplicates. No duplicates. It will not allow the duplicates. It will not allow the duplicates. Right? It will not allow the duplicates. So it means whatever the elements you are keeping into the set interface, like what are the classes are implemented by set interface, those classes will not allow the duplicates. So those will maintain uniqueness. Those will maintain uniqueness. Suppose you want the uniqueness, you don't want to duplicate records in your collection. So then we will go with the set interface. We'll go with the set interface. What are the classes are implemented set interface, we'll go with it. And it will not allow the null. There is one class called Treeset in this. There is one class called Treeset that will not allow the null in a Treeset. Okay, these are the major differences. These are the major functionalities between major functionalities of your set interface, or I can say major characters of your set interface, right? So there are few classes who implemented the set interfaces. Your set interface has been implemented by the first one is Hashset. Other one is Linkedhashset. Other one is Linkedhashset. The last one is Treeset. These are the three classes implemented set interface. These are the three classes. im- These are the three classes who implemented the set interface. One is Hashset, Linkedhashset, and Treeset. What is the Hashset? What is the Hashset? This is a class. As I said, this is a class. Who will main who will who will maintain the uniqueness by using hashing. What is the hashing, guys? Hashing means it maintain the unique objects by using hash code. Let's see here. Let's try to understand what is a Hashset. Hashset. So it is a class. So as we know that it is a class, and internally it uses the hash table. Internally it uses the hash table. Internally it uses the hash table for storing the data. What is the hash table? We will see that hash table later. Okay, we'll see that how the hash table looks and how the data will load into hash table. Okay, so as it is implemented, set interface, so he will also get all these features. He will also get all these features except null. So it will also allow it will allow the null. It will allow the null, right? So if you see here how to write a hash set. So let me explain a little bit about the hash set. It will not maintain index, no index. If you don't have index, no order. If you don't have index, no order. And the major difference is no duplication. No duplication. It means no duplication. It will not allow the duplicates. It will not allow the duplicates, right? So let's see how to. Okay, so if you want to see what are the methods are there in this, the same way. So go to your, where is that, where we are using this. Yeah, here it is there. Go here, go for Hashset. Go for Hashset. So look here, Hashset, Hashset class. Your Hashset class implemented again serializable, clonable, iterable, collection, and set interface. Anyway, these are common. These are common, right? These are common to set, list and set. So these are in the list interface. What other classes are there? They also use a serializable, clonable, iterable, and collectionable. They are also same for other classes in the set interface. But the major thing is it is implemented set instead of list, right? So these classes are under set interface. So if you see here, this also comes with the three different constructors. So empty constructor, or you can say a default constructor, with while creating itself you can pass the collection object, or you can also define the initial capacity. So what is initial capacity? We already discussed yesterday. And also you can provide the initial capacity and load factor. What is the load factor? How it is different in a, set interface and linked interface. See, in the list interface, whenever the data you started keeping inserting, whenever it reaches to some certain size, what it will do, it will double the size. It will double the size. The size will go double, right? So, but when it comes to here, when it comes to the set interface, it will not double the size. It will be having something called load factor. So how much has to be improve the size? Okay, 75%, 0.75, it means 75%, 50%, 20%, you can specify that. The default load factor is 0.75. The default load factor is 0.75. The automatically it grows, right? It will not grow like a 200%, like 100%. It will not double the size completely. So it will uses the load factor for the increasing the size automatically. Here also same, guys. So nothing more methods. Here also same. You can add the elements, you can clear it, you can clone it. Clone is further creating one more. Okay, it will, you can check, you can contains, you can check is it empty, you can iterate. Iterate means traversing through. You can do iterate, you can remove, and you can find the size of it. Sir, I didn't find anything get here. So you don't have a get in this, because how will you get? You don't have an index. If you have index, then only you can get the elements, right? If you have a index position by passing something, you can get it. But if you don't have position to identify, you don't have something to identify, then how will you get, right? So that's why you don't have a get here. Clear? Okay, let's look at a simple example. Let's look at a simple example. The Eclipse is closed. Let me open my Eclipse. By the time the Eclipse loads, any doubts? By the time it loads, any doubts? Harika, Kishore, others? The major difference between the set interface and list interface is set will maintain the uniqueness. Set will not allow the duplicates. There's a very major difference, guys. So when you have something where you want to, what's happening with this project space, I don't know. What's happening every day? Something went wrong. It's not able to identify the full path. The projects are not loading into this. Okay, just import it as we did yesterday. Something is wrong with it is going wrong with this. I don't know why, but I will look into it. Not a problem. It's not able to load, maybe due to memory, or I will see why. Okay, so 1 second. Why only one project? Hadoop hands-on. We have selected before Java hands-on, right? That's why it comes Hadoop hands-on. Yeah, some memory issue, guys. It's a memory issue. Okay, fine. It's okay. I'll look into that later. Not a problem. So the major difference between our list interface and set interface is duplicates. So whenever you have a requirement like you should store only unique objects. You should store only unique objects. You should not allow the duplicates. We will go with the list interface. What are the classes are? What are the classes? What are the classes are implemented by? What are the classes are implemented by? Implemented by set interface. We will go with them. Okay. let's just say remove. Guys, while you're deleting the project from workspace, do not select this. Okay, if you select this, delete the project content on the disk. It will delete from the disk also. Don't select that. If you want to delete from the disk also, not only for your workspace, you want to delete from disk also, you can select it. But be careful while doing this in the real time as well. Okay, so sometimes we'll be selecting that. So, so when we select that, what will happen? It will delete from disk as well. So if you delete from the disk as well, sometimes we may need it as a backup. Still, that few projects are not allowed. Why? I don't know what's going with this tool. Maybe memory. So many things are going. Yeah. So if it is on, I'll show you on writing on program and we can discuss. See here, let me write a small program here. Where is as simple as your array list. Create Hashset object. Set equal to new Hashset. You can go with this, or you can go with new Hashset of. If you have any other Hashset already, you can pass this set here, or you can go with the new Hashset of. You can go with the Hashset of the initial capacity. You can go with some capacity. Okay, you can go with something called new Hashset of new Hashset of. As you see in this in the this here, you can go with this constructor as well. There are four type of constructor where you can pass initial capacity and load factor. You can pass the your initial capacity and load factor, right? So constructor creates new empty set the backing hash map that it will backing hash map instance has default initial capacity 16. Default it will be 16 and load factor is 17. As soon as it's getting reached, the load factor it will be increasing the size. It is increasing the size, right? It is increasing the size. Something you will be having what is a load factor. You can understand the by load factor from here. Okay, so let's move there and you can specify hash set what is your initial capacity and what is your load factor. Both you can specify like this. Okay, so let's check whether our eclipse is up or not. Yeah, so as I shown yesterday, we have already some collections are already there because we have executed before. Employee set interface, and we have something called set demo. Guys, whenever we're practicing either set demo, list demo, don't practice with the your primitive data types, and also practice with the objects. This is very much important to you should understand how will I create objects, but real time you never I mean, it's not in the never, but most of the cases you will be putting into objects into your hash map or hash set, whatever the class it is, hash map or a hash set or link array list or linked list or vector, right? So what we will you may using for normal primitive data types, but you will use more you will use for more objects like this, d1, d5, d6, object like this. You're putting objects. You're putting objects, right? So be practicing them. So how to write an object? See here, I'm writing my dog class. If you go and see the dog class, and if you go and see the dog class, why it is implemented hash code, why it is implemented equals method? Because, okay, I'll explain that. First, let's see how you write with a primitive data type. See here, hash map. I'm taking a strings. You can also now you can also go with without iterators. You can also go with without it without generics. You can also go with without generics. Okay, and you can use the iterator here for iterating to each and every element. To iterating through each and every element. So does it mean that can't you iterate through for loop for each condition? Yes, you can iterate through for each condition as well. You can iterate through for each condition as well. You can specify like this. Okay, so you have added some elements as I shown the some method. This also has a very limited methods to understand, very less methods. It also has very less methods. So one is add method, clear method, clone is it's anyway it's from it object class, it's not from the this class. And you have something called contains. You are checking whether it contains or not. You have something called is empty, and you have something called iterator for iterating that, and you have something called remove and size. So can I use a list iterator here? No, you cannot use a list iterator. List iterator is for the completely list interface. Okay, you cannot use a list iterator here because the list iterator is for your list interface. Okay, let's see, compile this code and check. Look at here, the very first one, this very first one. Null, there is no order actually, it's not maintaining the order, right? So it is not maintaining the order. If you see, first null came, after d came, d is there before the last, and null came last one, e came, and the b, c, a. But a I have given twice. If you remember here, if you see here, a I have given twice, but your while printing it, a is coming only once. A is coming in only once. Okay, your a came only once, it means it removed the duplicates. And here what I'm trying to do, not only through iterator, for each also I can print the elements. So see here, I have printed the element. So if you want to print all the elements at a time, if you want to print all the elements, you can just specify println set. Okay, I just did this. So after that, I want to show you guys, I want to show you how to insert the objects in this. Suppose if you want to insert object, this is very much important, keep a note of it. If you want to put, if you want to put your objects into, because your string is an object, if you can load primitive data types, it's okay, internally it converts into internally it converts into objects, right? Apart from that, if you want to keep your own object, like custom objects, like a student, like a dog, or like an employee, like anything else you want to keep yourself into the set interface, anything, it can be anything guys, anything what you have written. Okay, so what you need to take care in that class, what are the class you are writing, right? Whether it's a dog or whether it's employee, you have to overload hash code function. You have to overload hash code and equals function. Why should I overload hash code, override, not overload guys. So you have to override hash code and equals function. Why? The reason behind it, so if by default they have a hash code function, right? So I'll show you a very simple example. I'll show you here very simple example. Let's assume that, sir, you said that these are from object class by default anyway they will be having, no, why should I write explicitly? Why should I write explicitly? Anyway they will be having internally, why should I write explicitly? Okay, so what I will do, oh, it's not cut, oh this, that is different, this is different. Okay, fine. So open, keep it this here. Go to, I want to show you this because the hash code, the differences in the hash code. I want to show the differences in hash code. Okay. Now I removed the hash code from the, observe guys, what I'm trying to show you here, I have removed the hash code and equals from your dog class. Hash code and equals from your dog class. Your dog class does not have a hash code and equals. Your dog class does not have a hash code and equals. Then what will happen when I compile this? When I will compile this, because I'm using the hash dog class here. I'm using the dog class here. I'm creating a dog objects and I'm creating a dog class here. And if you see here, I'm creating duplicates. D1, D5, D6 duplicates. And also observe, these are duplicate objects, but objects name may different. Objects name may different, but value of the object is duplicate. Value of the object is duplicate. Let me take this to make you understand. If you look at here, the police is a duplicate, right? The duplicate, right? This lex 1 police and security. Lex 1, I mean, there won't be no dog with a lex 1. So I'm just taking an example to differentiate, okay? So lex 1 police and security. So see here, if you see here, you're really able to understand, okay, it is not properly implemented the uniqueness. It is not properly implemented the uniqueness. You're able to understand that? Why? Because the default hash code functionality may follow differently. It may checking for different way, but we need to explicitly say that and what base you need to do hash code, right? And also look at this. The default the default hash code is not D1. See the hash code of the D1 here. See the hash code of the previous D1. Previous hash code, what we have explicitly written is, this is custom hash code. This is we have written. We have override. When we overridden, when we didn't override this is the default. If you see the differences here guys, D1 has this hash code and D1 has this hash code here, and this D2 has this hash code, and D4, if you observe here, D5, D6 and D1 all are having the same hash code. D1, D5, D6 all are having the same hash code in case of if you override. In case of if you override explicitly, but in case of what a compile generated, or you can say default hash code of your object class, if you use that, your hash code is different. Look at here. This is oh sorry, this is and this is. Why? Because the hash code what you have what the compiler is generating, that hash code is not based on the content. That hash code is not based on the content. If that is the based on the contents, it could have clearly say that no, it is not, it is you cannot allow the duplicates. It could have clearly say that. So but here, that hash code whatever it is generating for the dog objects, right, default hash code, where you are not overridden, it is not generating by content based. It is generating by different base, other base. Okay, let's look at now. I'm going to write myself. Now I'm going to write myself explicitly. I'm telling, I'm explicitly overriding, but even nothing is written here. I didn't write anything, I didn't type here anything. I just right click and overridden. Then I'm clearly specifying here, this is one, this is one. I'm clearly specifying what I want to hash code. My hash code looks should be in a each and every variable, based on each and every variable. Look at here, I have used legs, I have used type, I have used use, there is a variable called use. So it means I'm explicitly telling to a compiler while you are creating a hash code, you consider these parameters. You consider these all my parameters, right? If your default object class hash code may not be having these things, how he will know about your legs? How you will know about your type of the dog? How you know what is the purpose of the usage of it? Right? So that's the reason we have to override the hash code. When you override the hash code, you will be you having an option to expressly say that this is my variable, this is my variable. You create a hash code based on this. Don't create a hash based on the what is the default, right? So now go ahead, I have saved this. Now I'm going to compile this. Let's look at what is the difference here. Now look at, guys, I'm taking this and this both because I want to show you both. Where is that? This one, hash set, this one only, right? Now look at, now look at, I'll put it here only for sake of comparing. Now see, guys, it is properly validated based on the content. Here you got 1 2 3 4 5 objects you got, but here only 3 objects. If you see here, 1 2 3, these three are duplicated. But when you see, after overriding your own hash code, it's a clearly checking the uniqueness on each and every element in the specific object, right? That's the reason you have to override the hash code when you are worrying about the uniqueness. Guys, to keep in mind that you have to override the hash code when you are worrying about the uniqueness in your own classes. You may ask immediate question, sir, what sir? You said my integer, my string also uses the hash code, right, internally. Then how? I didn't specify what on what base it has to take. Very good question. But your internal string by default overridden. It's not using objects wala. It is overridden in a string class. If you see, if you go and see in the string class, it is overridden hash code. It is overridden hash code. But your dog class is your class. You are writing explicitly. When you are writing your own class, you have to override hash code and equals. This is very much important, guys. This is really important. Not only here, whenever you are keeping in a collection and you want to do some sorting, so you should uniqueness. You are mainly worrying about uniqueness. Forget about the sorting and all. When you're worrying about uniqueness, you should do with the hash code functionality. You have to override the hash code and equals. And also, if you guys remember, we already discussed about the contract between US hash code and equals. Why? What is the different? What is the contract between these two? Why should I override his equals? Why should I override hash code? Please go through it one more time. Okay, to make it properly, to compare properly, to check properly, so we need to override both. So but here it will compare the based on the hashing technique. Your hash set is work based on the hashing technique. Clear, guys? So let's look at linked hash set. Linked hash set as similar as your hash set. What is a hash set? No duplicates, no order. Very simple. No duplicate, no order. When it comes to hash set, very simple. Linked hash set. Whenever you see linked, that's what I was telling yesterday. Whenever you see linked, it will maintain the order. Remaining features are same. Remaining features are as similar as your parent, but only one feature is when you look at the linked, it maintains insertion order. What does it mean, sir? Here, if you see here, I need to add one more point here. I mean, I'm feeling to add one more point here to make you very much clear. No insertion order also. No insertion order also. But not for all of this hashes, right? It is for your hash set. No insertion order, but when you go with a linked list, when you go with a linked hasset, not linked list, when you go with a linked hasset, linked hasset is from the set interface. And you're going with this, no duplicates, agreed. I know set is not allowed, no dupli, no index, understood. But is your linked list maintain order, is your linked list maintain index? I'll show you. No, but it will maintain the insertion order. It will maintain the insertion order. Let's look at, guys, what are the methods are there in this, in the linked hasset. Go to here, linked hasset, linked hasset. So if you also see here, hasset, linked hasset, and serializable, as I said, common, clonable, iterable, collection, and set. Okay, no extra interface. Linked hasset as similar as that, and your with collection, with initial factor, load, initial capacity, and load factor. Okay, let's coming to methods. It's coming to a method. See here, what are the methods are there in hasset? All the methods will be available here. All the methods will be available here. And what are the methods are there for abstract set? So here, was specific to linked hasset, there are no methods. Specific to your linked hasset, there are no special methods. Your add all, clear, contains all, equals, hash code, all this will come from where? Your set interface. All these are coming from set interface. Anyway, those methods you can make use of them. Some methods are coming from your object. Wait, notify, finalize, these are. And some methods are coming from abstract collection, but we didn't see what is abstract collection, so not to worry at this point. Abstract set, the parent class of your set is your class is abstract set. You can look at here. Your parent is Hashset. Your linked Hashset parent is Hashset. Hashset parent is abstract set. Abstract set has parent is abstract collection. Right? So in the if you see a detailed architecture, you will be having a collection. Below collection there will be something called abstract collection. Below that you will be having abstract set, abstract list. So they will be having another abstract sets, but we didn't see them in detail, so not required as well. Okay, for time being. Doesn't mean that it's not, should not know about them, but we should know. Okay, for our Hadoop course, we don't need to know that much detail. Okay, and let's go here. Where is this? Let's look at here. No order, no duplicates. Order whichever, what are the order you entered? Okay, A, B, E, A, C, D. Okay, I entered this order and I'm printing them. Okay, I'm printing them. Let's look at here. A, B, E, A, C is already available, no? So C will not take. D and null. Sir, you said null is not allowed. Null is not allowed only in Treeset. That's why I explicitly said null is not allowed in Treeset. What is the difference between the Treeset? I'll tell you that. What is a Treeset and how it is different from others? I'll tell you that. Not to worry. Clear? Clear about the linked hasset? Linked hasset as similar as that. So you no need to worry about duplication when you are not worrying about the duplication, but when you are worrying about the order which you are entered, go with the linked hasset. Go with the linked hasset, right? And there is another class implemented by your set interface. There is another class which is implemented by set interface. That class is Treeset. The class is Treeset. Very simple, guys. Very simple. Wherever you see a tree, it means it is a sorting order. It is sorting order. What is the sorting order? How it is different from normal order? Normal order is the order you are inserting. Sorting order is the it is sorted based on the alphabetical order, or sorted based on the ascending order. Sorted based on the ascending order. Treeset, that's the only difference, guys. It will not be allowed the duplicate, but whatever the objects you are keeping in this, it will order, sort. It will do a sorting. It will do a sorting. So you have all add method and all same. Add all, the remaining everything is same. But if you should make sure that your Treeset will not allow the Treeset will not allow the null value. Why? Because your Treeset will not allow the null values, because let's say I have something called Ravi, one object. I have something called Veera. I have something called Kumar, and now I'm putting null. Okay, so while I'm putting into Treeset, what it will do, so which one will come first? It will check Kumar, then Ravi, because internally what is happening, these are getting comparing, these are getting compared with other, right? These are getting compared with others. So when they're getting compared with others, when you compare with the null, is there any point to compare with the null? Is there any value to compare with the null? You cannot compare with the null. You cannot call any method on the null, right? So internal it is calling compare method on the each object, compare to method, right? Compare to method on each object. So how can you compare your object with this object, this null object? So when you say null dot compare, it will throw null pointer exception. So that's why whenever you see a tree, whenever you see any class the name with the tree, we should understand one thing. The one is it has a sorting order and it will not allow the duplicates. Extra features for the linked list. What is extra feature? Wherever you use the linked Hashset, wherever you see linked, wherever see a linked, it is maintaining the it insertion order. Wherever you see a tree, wherever you see a tree, it can be a tree set, it can be a tree map. There is one more, we'll talk about that. So whenever you see this, internal it maintains the sorting order, ascending order. So if you are worrying about the order, you want the sorting order, then you go with the tree type of classes. So in that, one of the classes is in the for set interface is tree set. Sir, okay, I understand. I go with the tree set. If it is a integer, as we said, integers already has a method to compare internally. Comparable interface. If you guys remember, we discussed comparable interface, right? They already implemented the comparable interface. What if I write my own dog class? What if I write my own dog class? It's a very good question, guys. If you write your dog class, you have to implement comparable interface. You have to implement it. You have to implement it, right? You have to implement it, and you have to provide your compare to method. You have to provide your compare to method, and you have to explicitly tell on what basis you want me to sort. On what base you want me to sort. You want me to sort based on the number of legs, you want me to sort based on the usage, you want me to sort based on the type. You have to specify in your compare to method. You have to specify your compare to method, right? That's why in a tree, when you're trying to put any object, custom object like your own object into tree set, that class should that class should that class should implements comparable interface. So there is something called comparator, no? Can I do that? Please do an experiment on it and tell me tomorrow. So I want to see an example from there. You write a class, dog class, implements your comparator interface, override the compare method, and check whether I am able to do it or not. If it is a comparable, your tree set can understand easily. Okay, I need to call the comparable method of or compare to method of dog. Your tree set knows it has to call compare to method of your dog class. Then how my tree set knows how to call compare method from the comparator? Compare method from comparator. Please look at it. Please try it. Okay, please try it. So if you'll understand. Okay, so another, that is the one exercise. You take it as an assignment. Another assignment. Sir, you are telling it's an ascending order. Is there anything I can do in a descending order? It's also a very good question. You try it. You try it. These are 2 assignments. I want to see these 2 programs from you end of today. Okay. So that's why when whatever the class you are writing, your dog class, what your employee class, whatever the class, you look at here. I have something called employee class. So employee class also implemented comparable interface, and it has overridden the comparative method. That's over in the comparative method. The employee is telling that he want to sort based on the ID. Your dog is telling that you want to sort based on the usage. So what are the different objects can say the sorting order differently, right? You should define while you are inserting into Treeset. You should define what is the sorting order, guys. Please try to understand the Treeset. Treeset is little important. Look at guys here. Treeset. It came in a sorting order A, B, C, D, E. And also if you see this, anyway it will not allow the duplicates, that we know that. Look at guys here. So what we have said before, it has to sort based on usage. Home, pet, security. Home, pet, security. Correct? Is it ordered? Is it ordered or not? Okay. If you change my type, it will order based on the type. If you change the legs, it will sort based on the legs. Okay, that's okay. Now look at the employee. Here I am keeping employees in this. Ravi and Veera, both are duplicate objects. As I said, we have to override the hash code here. So both are, the content is same, but the object names are different. But when I'm explicitly saying my employee set class has to override the my employee set class has to override what to override, guys? Your hash code, to make sure that it is giving a different hash code. Look at guys here. I'm specifying ID, name, salary. Okay, so you should be very careful while dealing with the uniqueness. So while you are dealing with, you want uniqueness, you should override your hash code. If anyone asks why should I override hash code, anyway my object class has the hash code, but whatever the class you have written, in that you will be having your own fields. How it will compare, how your object class knows about your field. Your object class hash code method will not know about your fields, employee ID, employee name, salary, something blah blah blah. That hash code functionality work based on the whole object, but you should explicitly specify this. You take this element, you take this element, you take this element. You have to specify that, right? So that's the reason you have to override hash code. Guys, this is a very most important interview question. Why should I override the hash code when I have a hash code from the object class? So to get the proper uniqueness, to compare each bit by bit, like each element by element, why have to override my hash code? Why? Because my object class hash code method does not know about what are the fields I am using in my class. So what are the fields I'm using my current class known by my current class only. So in my current class I have to override hash code method. That is the reason, sir. That should be the answer. That should be the answer. Okay, so coming to this one is your set. You have given your hash code equals, because I'm going to put this employee set into tree set. If you were keeping into tree set, you're keeping into tree set. If you're keeping in a tree set, it should be comparable. It should be comparable. Sir, why you have overridden two string method? Can someone tell me why you have overridden two string method here? Because I'm trying to print in the console. I'm trying to print in the console. Here, I'm trying to print in the console to make you a difference, to show you the difference. I have done this. Okay, so I want you guys to do an experiment, and send me the results. What are the assignments I have given to do assignments, right? The collections are most important, guys. You should understand very well. So if you are going as a fresher, or if you are going as a experienced on Java, or whatever the way you're going, the collections questions will be there. Without having a collection question, no interview will be there. No interview will be there. If any of the company is not asking any of the interviewer is not asking the questions from the collections, it means either he don't know, or either he don't know or the reason might be he might not knowing that, or he might have forgot. He might have forgot to ask the collections thing. Okay, if they didn't ask the collection interview questions, don't join that company. You should understand. You should know what is the stamina of the team. What is the capability of the team. What kind of team they are. What kind of questions they're asking. If you face a difficult questions, it doesn't mean no, the company is very bad. If you're facing a difficult questions, it means that they are really working good. Okay. Okay. Okay, so look at, guys, here. This is my employee hash set and this is my tree set. So in the hash set, I said I didn't specify any sorting order, but when it comes to the tree set, I specified my order should be on based on ID. My order should be based on ID. My true string, my comparative method is based on ID. So that's why both are, it's coming in order. This is not coming in a order. This is about the set interface, guys. This is about the set interface. We will see map interface tomorrow. If you guys have any doubt